Okay, so I want to talk about an intro into graphing. This comes from section 2.1 in your textbook, where we start talking about the coordinate axis, we start graphing. The first thing we talk about, however, are two formulas, the distance formula and the midpoint formula. But first, I just want to talk about the coordinate axis, where we graph and try to bring back some memories. We call this the coordinate axis. Each one of these dots locate a certain position or a point. The x-axis is your horizontal axis. You can see the x right here. The vertical axis, up and down, is the y-axis. We label a point, any point on this axis, by two numbers or two coordinates. The x comes first, just like the alphabet, and then the y value or the vertical position. If I had this point right here, we can find out the location of that point by starting at our origin, and you can tell it's your origin. Look at the numbers. You have 10 and then 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So you know y right here is 0, because you can look at the increasing numbers also going up. The x-axis, the decreasing numbers from the right, increasing from the left, and they all come to 0, 0. That's what we call our origin. This is where the x-axis is 0 and the y-axis is 0. To find this point's location or coordinates, let's start here. So the first value, we would be moving horizontally on the x-axis just to kind of find out at what value this point lines up with. So it would be -1, -2, -3, -4, -5, and -6. So this would be at -6, and then to find the y position, wherever you count to the left, stop and then just move up. 1, 2, 3, 4. So it is up 4 units. Let's do this one. Find out what position this is. Start back at your origin. We come out 5, 6, 7, 8, 9. Looks like it's lined up with 10. And then when we get to where the 10 value is, go down to the point, which would be down negative direction, -3. So that's how the movement works. Let's graph some points the other direction. So let's graph 2, 5, or plot. In this case, we're plotting points. So let's plot 2, 5, 3, -6, and 0, -4. To plot 2, 5, again, begin at 0, 0. This says move x 2 spots, y 5 spots. So go over 2 and up 5. Both are positive numbers. So you would go both positive directions. 3, -6. Let's start over. +3, 1, 2, 3. And -6. So down 6. And then lastly 0, 4. So sometimes, or 0, -4. Sometimes one of the values may not move at all. It just may hang out in the 0 position. X is 0, so we stay and then travel down 4. So that coordinate right there is 0, -4. So sometimes, however, we want to find the distance between 2 points. So this distance right here, as the crow flies, just straight over there, We would need to know those endpoints, though, first, wouldn't we? Let's practice it. Let's see. This coordinate is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. This one would be 1, 2, 3, negative direction. 1, 2, 3, and up 3. So I need a way to find the distance sometimes. Now this would come in handy if you had like triangles and you needed to find the length of a side. Application problems, you had a baseball diamond, you needed to know the length from first to second base or whatever. And I'm not talking about a standard baseball field. I'm talking about the sandlot, one you play with. But anyway, there is a way to do that. There is a distance formula, another formula that we need to learn, but you can see the application. Distance formula is the square root of, and the 2 points have everything to do with it. So let's just call this the first x and y. This is the second x and y. And we're going to find the distance. The formula would be the difference in the x value squared plus the difference in the y value squared. So we just plug it in. You see both x's are together, both y's are together. That will help you maybe learn the formula. So let's just plug them in. This is point 1, which has the 1, 1, and point 2, which has 2, 2. Doesn't matter which one is point 1 or point 2. But I'm just going to plug in the values the way I have them assigned. x2 is 6 minus x1 is a negative 3. Be very careful with your minus negative signs. Don't shortcut it. y2 minus y1 squared. And then we just work it out. So 6 plus 3 is 9 squared. 6 minus 3 is 3 squared. And just carry it out. Don't get in a hurry. 81 plus 9 would be the square root of 90. Now we could break that down if we wanted to, but we're probably going to do an exercise Monday to play with this, so we'll just leave it like that for the moment, okay? And we know that the square root of 100 is 10, so this is a little bit less than 10 feet, 10 inches, 10 centimeters, whatever you're trying to find the distance of, whatever the unit is that's used. So you could back up the video and play with this again, or we could just do another one. On your next sheet, I have the distance formula written for you. And I've shown you kind of where it comes from, but we'll talk more about that in class. I really just want you to get an understanding of where the distance formula is used, where it comes from, how we're going to use it, and just kind of how to apply it. So we have the distance formula. Find the distance between point 1 and point 2. So we can name point 1 and point 2. You don't have to assign that and write it down. Sometimes it's just a little bit easier, so you don't have to think about it. x2 minus x1. So negative 2 minus 3 squared plus y2 minus y1. So 8 minus a negative 5 squared. You have negative 5 squared plus 8, 9, 10, 11, 12, 13 squared. Be careful how you input this in your calculator, those of you who don't think you can do anything without one. But negative 5 times negative 5 is going to be a positive number. I hope you've learned that from the quadratic formula. 25 plus 169, square root that is. So 25 plus 169 is the square root of 194. That's going to be 13 squared is 169. It's going to be somewhere around between 13 and 15. Let's see what 14 times 14 is. 196. So it's just shy of 14. Is what that is. Doesn't matter. We're just learning how to apply the formula. So why don't you do this one and then check it with the video. That's at 8. Finding the distance between these two. Just apply your rule. Whoops. 2. 2 minus 8 squared plus 7 minus 4 squared. That is negative 6 squared plus 3 squared. So 36 plus 9 is square root of 45. If we were going to break it down, that's the same as square root of 9 times 5, right? Or 3 square root of 5. Doesn't hurt to practice. So you have 3 really good ones to practice and make sure you know the distance formula, because we won't spend a whole lot of time on it. We're going to move on to graphing. But you need to know it. You're going to need to know it. And then lastly, and we'll just do one. Sometimes, let me just, well, I can take my sheet back. There's also something we call the midpoint. And we're talking about a number line still. It's the midway point. The point that's equidistant from the endpoints of the segment. So if we just lay down a regular old number line, and this has a XY value, and this has an XY value, what is the point of the one, or what are the coordinates of the point in between? Right in the middle of it. So let's see, I'm going to graph these, I think. We have negative 7 and negative 5 right there. And I have negative 2 and 10, 11, 12, 13 way up there for these midpoints. So we have a line segment. And we want to know what the coordinates are of the point right there in the middle. We'll define those. We just follow our midpoint formula. Add the x's together, divide by 2 to get a new point. Add the y's together, divide by 2 to get a new y coordinate. So according to the midpoint formula, add our x's together and then our y's together. So you're finding the average of the x's and the average of the y's by dividing both by 2. Negative 7 plus negative 2 divided by 2. Negative 5 plus 13 divided by 2. So let's see. We would have negative 9 over 2 and let's see, 4. I guess it would be 8 over 2. So negative 9 halves and 4. Negative 9 halves would be negative 8 and 1/2. Or negative 4 and 1/2. So negative 4 1/2 and then up 4 puts me right back on that line, doesn't it? Yeah, using our midpoint formula. So let's do another one. One more. Let's find the midpoint between 3, 7 and -2, 4. So those are my 2 points, and I believe we can find the end point. So I'm just going to graph these. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So starting at my origin, to the right 3, up 7. And starting at my origin, I go left 2 and up 4. So we're just talking about somewhere up in here. Not sure what that'll be. And you can't do it with your eyes. You can't eyeball it because there's so many variables, especially when I'm hand drawing it, isn't it? So let's find midpoint. I know that the midpoint, I add up my x's, divide by 2, comma, add my y's, divide by 2, because I'm getting a new point, the point in the middle. And remember, all points are written like that. So let's add our x's together. 3 plus -2 over 2. 7 plus 4 over 2. So we have 1/2 and 7, 8, 9, 10, 11, and 11/2 would be our midpoint. 11/2 is going to be right at 5.5. So 1/2 and 1, 2, 3, 4, 5.5 right there. So it's just to the right of the y-axis. So please go through these and make sure you're very familiar with these formulas and understand plotting a point.